In fluid mechanics, we're going to make a concerted effort to keep track of the dimensions of the problems that we study and that we analyze. So what do I mean by dimensions? Well, here's this book as an example. This has dimensions of height, width, depth, and all of those are dimensions of what we call length. Okay? So the first key dimension we have is the dimension of length. Now, the second key dimension we have is it sort of describes change. If this thing is moving, and if something's changing in time, then we're going to have some sort of dimension of time involved. Okay? So length is key, time is key. Another important one's going to be weight or mass. How heavy is this book? The other key dimension is going to be mass. And then the last dimension we're going to be thinking about has to do with sort of the energy it stores, and that can be scaled by temperature. So we'll use the Greek letter theta to represent temperature. Okay, so it's important that we keep track of the difference between dimensions and units. So a fundamental dimension is length, but the units of length are things like meters, centimeters, feet, inches, miles, and so on. There's many different dimensions of length. Likewise, there's many different dimensions of time. We have seconds, hours, minutes, days, years, and so on. Mass, we have a lot of different options. We've got grams, we've got kilograms, we've got slugs, we've got pound mass units. And when it comes to temperature, we also have a bunch of different options. We have degrees Celsius, we have degrees Rankine, we have degrees Fahrenheit, we have Kelvin. So all these are examples of different units, but all these units express a dimension of temperature. Units expressing a dimension of mass, time, and length. So the four key dimensions are length, time, mass, and temperature. Now, there are other important properties that are combinations of these four dimensions. For example, force is just equal to mass, length, per time squared. So mass times acceleration gives you force. So similarly, volume is equal to length cubed, area is equal to length squared, a shear stress, say sigma, a shear stress, that's going to be equal to force over an area, or force over length squared, and that's going to be mass, length per time squared per length squared, or mass per length per time squared. So you can see how many different properties of the system can be expressed as different combinations of these four fundamental properties. So in this system, I've used mass as a fundamental dimension. There are other systems where force is used in place of mass. So there are some options for how you do this, but I recommend when you do dimensional analysis that you keep track of length, time, mass, and temperature.